exponent laws for multiplying powers, dividing powers, and powers of a power. I'm going to ask you to copy the table onto a piece of paper and pause the video while you convert each expression to expanded form and then rewrite it in simplified form. Before you start the video again, make sure that you kind of take a look and see what pattern exists for multiplying powers with the same base. Hopefully you've paused the video and done your own work, because of course that's going to make it better for you to remember and understand where the answers came from. If we rewrite the power x squared in expanded form, it's x multiplied by x. And then if we multiply it by x to the exponent 4, that's x multiplied by itself 4 times. And if we rewrite that in simplified form as a power, that will become x to the 6, because of course a power is a shortened way for for expressing something multiplied by itself multiple times. Y squared times y to the 5. Again, it's y multiplied by itself twice, multiplied by y multiplied by itself 5 times, for a total of y being multiplied by itself 7 times, and that's why there's an exponent of 7. A to the 7 times a cubed would result in 10 a's multiplied together, and as a power, that would be a to the exponent 10. Now, if I take a look at what's happened here, take a look at the exponents. Hopefully, you've kind of connected the dots on the exponents here. 2 and a 4 is a 6. A 2 and a 5 gave a 7, and a 7 and a 3 gave a 10. So hopefully you've recognized that when you multiply powers with the same base, of course, all you have to do is add up the exponents and keep the base. So if we want to use the pattern to simplify the expressions, x to the 5 times x to the 4, again, pause the video, write the expressions out, and attempt to do them yourself, showing all your work. You can watch example A first, though, before you pause it if you wish. X to the 5 times x to the 4, the base is the same, we're multiplying, so that'll be x to the 5 plus 4, which is x to the 9. X to the 4 times x to the 9, again, I've got 4x's being multiplied and then being multiplied with 9x's being multiplied together, so x to the 4 plus 9, or x to the 13. Get in the habit of this step right here. As you do your homework and you work through practice questions, start by using that step. It will reinforce in your mind what you did to get the answers. And think about why you're doing it. 2a to the 7 times a to the 5 means 2 multiplied by 7 a's multiplied together, and then multiplied by 5 a's multiplied together, or a to the 7 plus 5, and the 2 just stays a coefficient for 2a to the 12. In part D, we can multiply the coefficients. Sorry about that. When we have two monomials multiplied together with coefficients, we can just multiply the coefficients, so negative 2 times 3, and the a to the 4 times a cubed. So we end up with a to the 4 plus 3 for the exponents, and negative 6a to the 7. And part E is no different. We're still multiplying 24y's with 2y's and 5y's, so we can just add the exponents again, and we end up with y. Oh, that should say y. Sorry for the typo. Y to the 31. Now let's take a look and see how that changes if we're doing division. So x to the 10 divided by x to the 4. Again, I'm going to ask you to pause the video, rewrite them in expanded form, and then as simplified powers. If you take the time to do this yourself, you're more likely to remember what you did. Okay, so if you look at the first one, we can see that we've got 10x's in the numerator and 10x's in the denominator. And we know from our work with rationals in grades 7 and 8, we can reduce. So all of these things reduced away, and I was left with x to the 6th. And if I look at this one in expanded form, again, I've got 5y's in the bottom that will reduce with 5y's in the numerator, and that will result in y to the 7 being left. And a to the 7 over a to the 3, again, there's 3 a's being multiplied in the denominator, and they can reduce with 3 a's in the numerator. Hopefully after looking at the pattern in the last one, you have a general idea quickly of how to get the simplified power. Got a 10 and a 4, turned into a 6. A 12 and a 5, turned into a 7. A 7 and a 3, turned into a 4. And hopefully you realize that when you divide powers with the same base, you simply subtract the exponents and keep the base. Again, pause the video, try and do these examples on your own. X to the 5 divided by x to the 4, we subtract the exponents, we're left with x. We don't need to write the exponent of 1, it's understood to be there. X to the 9 divided by x to the 4 will be x to the 9 minus 4, which is x to the 5. 2a to the 7 divided by a to the 5. Again, the 2 is the coefficient. 7 take away 5 on the exponents, you get 2a to the 2. Now part D is a little bit different because we have coefficients and we're dividing by everything in the bracket that follows. So I could think about writing that in fraction form as 12a to the 7 over 3a cubed. And I can easily see that the 12 must be divided by the 3 and the a to the 7 must be divided by the a to the 3. So I end up with 4a to the 7 minus 3 or 4a to the 4. Take a minute, pause the video. Think about how the answer to part E will be different than part D, or is it different? If I look at part E, I am saying divide by 3, not by 3a cubed, because my good friend BEDMAS tells me to do division and multiplication in the order they occur. So what would happen here is I've got 12a to the 7 divided by 3 when I write it in fraction form, followed by the a to the exponent 3. So I'm left with 4a to the 7 plus 3. Two very different answers for two questions that look almost the same. So beware that you follow order of operations with questions like this. Y to the 24 divided by y squared divided by y to the 5. Again, simply subtract. BEDMAS tells me to do it in the order it occurs, so I do 24 take away 2 to get 22, but then I simply do subtract 5, and I end up with x to the 17. Finally, we're going to look at powers of powers. Again, pause the video and do the work yourself in order to remember it and retain an understanding of why things are occurring. X squared to the exponent 4 means x times x multiplied by the same thing 4 times. So really, I see x to the 8. Y cubed, cubed means y times y times y 3 times. So again, I see y to the 9. A to the 7 squared means a multiplied by itself 7 times, twice. So a to the 14. And if we look, what's my shortcut? 2 and 4 turns into an 8. 3 and 3 turns into a 9. 7 and 2 turns into a 14. So when we have a power raised to an exponent, we simply multiply the exponents and keep the base. You'll notice that we've kept the base when we multiply powers, divide powers, and have a power of a power. So if we look at part A here, x to the 5 to the 4th, we multiply the exponents to get x to the 20. X to the 9 to the 4, again, multiply the exponents to get x to the 36. Now, part C, D, and E are all very similar. Pause the video and look for differences before you move on. In part C, the exponent 4 is only on the power in the bracket, so the 2 gets left alone, and we multiply the exponents to get 2a to the 28. Now, if you look at part D, the exponent of 4 is on the bracket. That means everything in the bracket is affected by the exponent. So we end up with 2 to the 4 multiplied by a to the 7 times 4, which is 16a to the 28. And again, in part E, the same thing applies. Now, the negative sign is also part of the base because it's in the bracket. So it's negative 2 all to the 4, a to the 3 times 4, and we end up with 16a to the 12. In part F, y to the 24 squared to the 5. 24 times 2 is 48, and then we have to multiply by 5 to get 240. Things to remember in general, if we have if we have a product in the bracket, each factor, the x and the y, are both affected by the exponent, and the same thing happens with a quotient. The numerator and the denominator are both affected by the exponent.